Namaskar, welcome to Divine Chemistry. I am Dibyashri and this is my second video on basics of chemical bonding. So in our previous video we have discussed on various types of bonds, and in this chapter we will mainly be discussing on covalent bond because this chapter is majorly based on covalent bonds. And also in our last video we have raised the question on why do atoms combine. So in this video we will try to answer the question more deeply on why do atoms combine. So the first theory which was given in order to answer the question of why do atoms combine was by Lewis, and it is known as the Coulson-Lewis approach to chemical bonding. Now, since the theory which was given by Lewis was based on the electronic concept of an atom, so it is referred to as the electronic theory of valency. So what Lewis observed was that in the periodic table all the atoms like carbon, nitrogen, oxygen, hydrogen, all of them combines, but the elements of group 18 do not combine. We call them as noble gas. So what he observed was that all the atoms combine in order to become like group 18 elements, because group 18 elements do not combine and thus they are considered as stable. More simply, the atoms or the other elements of the periodic table combine in order to make their electronic configuration similar to those of the group 18 elements. So what Lewis observed was that all the elements of group 18 or all the noble gas possessed an electronic configuration with 8 electrons in their valence shell, except helium which have 2 electrons. So what he said that all the other elements combine in order to make their electronic configuration in such a way that their valence shell have 8 electrons, or hydrogen, since it have only 1 proton, so hydrogen tries to make its valence shell having 2 electrons and other elements tries to make 8 electrons in their valence shell. So that's where the octet rule came. So what it states that the atoms of different elements combine with each other in order to complete their respective octets, that is 8 electrons in the outermost shell, or duplet, that is 2 electrons in the outermost shell in case of hydrogen, lithium and beryllium, to attain stable nearest noble gas configuration. Now what are the Lewis symbols? So Lewis symbols basically they represents the valence electrons. Now in the formation of a molecule only the outermost electrons are involved and they are known as the valence electrons. Now what happens, the inner shell, their inner shell electrons, they are quite safe because they are held together by the protons, but the outermost electrons, they can participate in various reactions and thus they are known as the valence shell. And G. Lewis introduced simple symbols to denote the valence shell electrons in atom, and these symbols are known as Lewis symbols or electron dot symbols, because what Lewis did was that he represented the valence shell electrons with the help of simple dots. Now before learning how to draw the Lewis dot structures, we need to understand the significance of Lewis symbols. Now the significance of Lewis symbols is that the number of dots around the symbol gives the number of electrons in the outermost shell, and this number of electrons helps us to calculate the common valency of the element. That is why these electrons are called valence shell electrons. Means when we know how to draw the Lewis dot structures, we can easily find out the valency of a particular element. And please note this point, that the common valency of the element is either equal to the number of dots in the Lewis symbol provided there are less than or equal to 4, or minus the number of dots if these are greater than 4. Now how to draw the Lewis structures, let's learn about it. So step 1, calculate the total number of valence electrons of the atoms present, which we can easily calculate from the electronic configuration. Second step, in the species, if the species is an anion, then add the number of electrons equal to the units of negative charge, and if the species is a cation, then subtract the number of electrons equal to the units of positive charge. What this will give is the total number of electrons to be distributed in that particular element. Step 3, select the central atom, which is generally the least electronegative atom, and draw the skeletal structure. But remember one point, that hydrogen and fluorine usually occupy the terminal position. This is because they have only their valency is 1. They cannot combine with more than 1. So they will usually take the terminal position. Step 4, put one shared pair of electrons between every 2 atoms to represent a single bond between them, because as we have discussed in our previous video that a single bond can be represented by a pair of electrons, that is 2 electrons, and use the remaining pair of electrons either for simple bonding or to show them as lone pairs, keeping in mind that octet of each atom is completed. This point is important because whenever we draw the Lewis structure, the point that we need to keep in mind is the octet rule. We should always fulfill the octet rule while drawing the Lewis dot structure. Let's try it with an example. Let us see how to draw the Lewis dot structure of carbon monoxide molecule. Firstly, calculate the total number of valence electrons in carbon monoxide. Now carbon have 4 and oxygen have 6, so the total number of valence electrons here is 10. Secondly, let us calculate what is the total number of valence electrons it should have. Obviously carbon should have 8 electrons and oxygen should also have 8 electrons in order to complete the octet rule. So the total number of valence electron it should have is 16. Now this please note that all the atoms, they will obviously they will try to have 8 electrons in their valence shell except hydrogen, which will try to gain 2 electrons in their valence shell. So step 2 is quite simple. Thirdly, calculate the number of shared electrons. Now how to calculate it? We have known we have calculated that the number of valence electron it should have is 16 and the total number of valence electron it already have is 10. So the shared electron will be 16 minus 10, that is 6. And what is the number of unshared electrons? The total number of valence electrons that we have shared, and now see the total number of valence electrons in carbon monoxide is 10 and number of electrons shared is 6. So the total number of unshared electrons will be 10 minus 6, that is 4. So finally, as we have calculated the number of shared electron is 6, let us distribute equally. Since there are 6 electrons and to represent a single bond we need 2 electrons, then it will form, we found that it will form 3 bonds. So 3 pairs of electrons are shared, and in order to complete the octet we have seen that carbon need again 2 electrons and oxygen also needs 2 electrons. So by making the octet complete we have found that we can draw this structure like this. But one thing here to note is that, yeah, this structure is 2, there is no doubt. But one thing to note is that we know that carbon have 4 valence electrons. But here we have found that carbon is having 5. This is not possible. So we can say that in this structure, one bond is a coordinate bond which is formed. That is, those electrons are entirely given by oxygens. So this upper bond we can say it as a coordinate bond. Obviously, there is no difference after the formation between a covalent or a coordinate bond, but since we know that carbon have 4 valence electrons, we can say here that in the structure of carbon monoxide, 2 bonds are covalent and 1 bond is coordinate. I have also given here some of the other Lewis structures. You can take a screenshot of it. I have taken this page from Pradeep's. And finally, what are the limitations of the octet rule? Now, octet rule states that there should be 8 electrons in the valence shell, but in the formation of compounds involving hydrogen, we have seen that it gains only 2 electrons in its valence shell. So this can be considered as an exception of octet rule. Secondly, we have seen that there are formation of compounds like barium chloride, BF3, aluminum chloride. So octet rule states that there should be 8 electrons in the valence shell, but these compounds, they have less than 8 electrons in the valence shell, but still they are found to be quite stable. Thirdly, formation of compounds like phosphorus pentachloride, SF6, IF7, H2SO4, etc. These compounds, these are hypervalent compounds, means they have expanded octets. They have more than 8 electrons in their valence shell, but still they are quite stable. So this can be also considered as a violation of octet rule, and this can't be explained by the octet rule. Fourthly, formation of compounds of noble gases. Now what Lewis observed was that noble gases are stable, they do not combine with anyone, but it is found that even noble gas do combine. So this cannot be explained by the octet rule. Moreover, we have seen the formation of odd electron bonds or odd electron molecules in case of nitric oxide, nitrogen dioxide. So this can also be considered as a limitation of octet rule. Now these limitations were quite explained. These limitations are explained with the help of other theories which were put forward from time to time, and we will not discuss those theories in this video, but we will surely be covering those theories in our coming videos. And it was all for today. Please try to practice the Lewis structures at home. Try to draw the Lewis structures. It will be much helpful. And thank you so much for your patience. Thank you so much for listening to me. And if you like the video, then please give it a big thumbs up, and obviously share it with all your younger brothers and sisters, and do subscribe to the channel. I will be much happy for that. And stay home, stay safe, and take care. Thank you.